You see freight trains every day, but you have no idea what is inside. Each railcar is purpose-built for specific cargo. We will explain every type and rank them by importance to the economy. Boxcars once defined American freight. Their steel shells and sliding doors made them the backbone of rail shipping, carrying everything from canned food to refrigerators. In the late 1950s, boxcars accounted for nearly half the fleet and moved a third of all ton miles. Crews worked constantly to keep the doors rolling, greasing tracks, tightening bolts, and battling rust. Loading took muscle and time, about 20 minutes per car, even on a good day. But as the economy picked up speed, boxcars struggled to keep pace. Their fixed interiors and manual loading could not match the demands of just-in-time delivery or the scale of global trade. Containerization rewrote the rules. Standard 20-foot and 40-foot containers, first appearing in the late 1960s, could be hoisted straight from ship to rail to truck, untouched inside. The double-stack well car, introduced in the late 1970s, let railroads move twice the cargo in the same space. By the 1990s, automated terminals slashed dwell times. A terminal manager at a major Midwest hub puts it simply, a single intermodal train can move over 250 containers coast to coast with less than 4 hours of terminal time. The standard shipping container, measured in 20-foot equivalent units, now moves everything from laptops to jeans. In 2023, U.S. ports handled 54.3 million 20-foot equivalent units and over 15 million intermodal railcars crossed the country. That efficiency pushed the boxcar aside, shrinking its fleet by more than 90% since its heyday. As railcars evolved, new dangers emerged. Tank cars, built to haul hazardous liquids, became a national concern after the Lac-Mégantic disaster in 2013. 72 DOT 111 tank cars derailed in Quebec, 2 ruptured, unleashing a fireball that destroyed downtown and killed 47 people. Investigators blamed thin steel shells and a lack of thermal protection. The response was swift. The DOT 117 standard added thicker steel, full head shields, and 2-inch thermal jackets to withstand fires over 1,000 degrees for half an hour. As a hazardous materials safety engineer explains, the DOT 117 adds over 50% more steel and a thermal jacket that can resist a 1,000-degree fire for half an hour. By 2025, more than 70% of tank cars carrying flammable liquids will meet this standard, with the rest facing retirement or expensive upgrades. Innovation and crisis keep reshaping the railcar fleet. The boxcars fall, the rise of containerization, and the overhaul of tank car safety all show how engineering and policy keep redirecting what moves the economy. Coal once filled open hoppers from Appalachia to the Powder River Basin, fueling power plants and steel mills across the country. In 2008, U.S. railroads hauled over 1.1 billion tons of coal, nearly 90% of it by rail. But by 2022, that number had dropped to just 616 million tons, a 45% plunge in less than 15 years. Monthly open hopper car loadings fell in tandem, from 850,000 in 2008 to just 380,000 in 2022. The reasons run deep. Power plants are switching to natural gas. Environmental rules have tightened, and renewables have grown steadily. Railroads responded by retiring thousands of older hoppers, with some fleets cut in half, and shifting investment toward more flexible car types. Covered hoppers, on the other hand, have become the backbone of American agriculture. Each car features gravity discharge gates and sealed roof hatches, keeping grain dry from the elevator to the export terminal. The Association of American Railroads reports that covered hoppers now move around 180 million metric tons of grain every year, about a quarter of the country's total grain shipments. At a major Midwest grain elevator, the loading process runs like clockwork. Automated spouts fill a car in 7 minutes. Crews seal the hatches, and the car is on its way in under half an hour. A local elevator manager puts it plainly, Without covered hoppers, there is no way we could keep up with harvest. These cars are our pipeline to the world. Since 2015, covered hopper carloads have climbed 12%, buoyed by export demand and new biofuel markets, making them indispensable to both farmers and railroads. Gondolas offer a different kind of versatility. Their open tops and rugged steel sides make them ideal for hauling heavy, irregular cargo, scrap metal, steel coils, stone, and demolition debris. In 2022, U.S. railroads moved about 71 million tons of ferrous scrap, with roughly 55 million tons riding in gondola cars. Unlike coal hoppers, gondola volumes have held steady or even grown slightly, reflecting rising recycling rates and steady demand for steel. Scrap is often loaded by crane, sometimes in a single bite, and the cars can be swept out and reused within hours. Gondolas now carry more tonnage of scrap than open hoppers do coal, a reversal that would have seemed impossible a generation ago. Their adaptability lets railroads pivot quickly as markets shift, ensuring these cars remain a fixture in yards and mills nationwide. The contrast is clear. Open hoppers are shrinking along with coal, covered hoppers are vital to agriculture's steady flow, and gondolas prove their worth with every load of scrap. These shifts are not just about car design, they reflect the changing backbone of the American economy, where energy, food, and recycling each demand a different kind of rail car to keep goods and industries moving. Flat cars offer pure adaptability, just a steel deck, tie-downs, and the freedom to carry what nothing else can: turbines, excavators, armored vehicles. Chain binders and welded stanchions hold everything in place, but the real strength is in their ability to switch roles week by week, always ready for cargo that defies standard containers. For the auto industry, protection means everything. Auto racks changed the game, sealing up to 15 vehicles inside 2 or 3 decks and shielding millions of dollars worth of cars from the elements and theft. Mesh sides let air move through while keeping out debris and prying hands. At a single Midwest plant, one train of auto racks can move over 1,000 new cars, an entire dealership's worth, locked up and tracked from factory to showroom. The value is staggering. A fully loaded auto rack can carry over $1 million in new vehicles. Refrigerated cars, reefers, have left ice bunkers behind. Today's mechanical reefers use diesel-powered units to keep produce, meat, and medicine between -20 and +70 degrees Fahrenheit. Digital controls and remote monitoring let shippers adjust temperatures on the fly, guarding perishable cargo from California to the East Coast. Fewer spoiled loads and tighter delivery windows mean technology has redefined what is possible. Centerbeam flat cars specialize in lumber and building materials. A tall central steel beam runs the length of the car, balancing the load and allowing forklifts to unload from either side. Each center beam can haul enough lumber to frame more than a dozen homes. The reinforced symmetrical design speeds up every stop, keeping valuable cargo upright and schedules tight. Every railcar here is a solution, tailored to protect, preserve, and deliver economic value. Some railcars are designed with a single purpose: to solve problems that ordinary freight cars can't handle. The coil car is built as a cradle for hot rolled steel, with a trough about 24 inches deep, lined in thick pads. That depth is calculated just enough to keep coils weighing up to 50,000 pounds from shifting under sudden stops or sharp curves. The cradle's arc matches the steel's diameter, and heavy tie-downs clamp each coil in place. If a coil moves even a few inches, it can dent the frame or tip the car. Engineers use a 60-40 weight split, placing 60% of the coil's mass below the center line, dropping the center of gravity and anchoring the load. This lets railroads move steel at highway speeds, safely and efficiently. The well car takes a different approach. Instead of stacking containers high, its floor drops the lower container by more than 2 feet, lowering the combined center of gravity by 16 inches. That change cuts tipping risk by 12% on loaded trains. The well is usually 30 inches deep, just enough to nest a 40-foot container below deck. Reinforced end plates and twist locks secure the load, while sensors feed weight data to the locomotive.
Double-stack trains can now haul up to 250 containers at 70 miles per hour, all within the 20-foot, 1-inch vertical clearance allowed by North American rail standards. That means 45% more cargo per train mile without expensive upgrades. A 5-criterion scorecard that looks at tonnage, value, versatility, safety, and trend ranks each car. Intermodal well cars lead, followed by tank cars and covered hoppers. The numbers reveal what keeps the economy moving and where future investment matters. Every rail car on the tracks today shapes what arrives on store shelves, in factories, and at your table. As supply chains face new strains, these specialized cars remain the silent backbone of global commerce, proof that how we move goods still decides what is possible. Thanks for watching.